Ladies and gentlemen, welcome back to another live stream. Alright, so this is part 2 of this series. In the previous video, pretty much have made let's see, this thing right here. So in SDL3 GPU, so we got a mesh with a texture, right, and a skybox pretty much with a camera controller that you can move around. Okay, in today's video we'll see what we're gonna work on. I mean, I've done some refactors off camera, so we'll start by trying to explain those or reviewing those, and we'll see. Alright, so let me just copy the link here and let's go to where are we gonna put this? Streams. Alright, and you can join my Discord server in the description below. Find the link hopefully. Otherwise, just say discord.codechaku.com. Anyways, live. And let's go. Alright. I wonder if the stream is public. Let's see. So we'll start in a few minutes. Hello, Comported Box. Welcome back. What WSG means? Let's spin this thing, pin message, and let's go. Alright, so we'll start in the 5-minute mark, I guess. Stream I think was a bit late today. Yeah, it's already almost 3 AM. Yeah, I slept up. Okay, I'm done with my coffee, so I guess let's start already. Okay, so first of all, the developer of the binding have actually noticed my previous live stream, which was interesting. I like it when the creators of the projects I'm using notice my creations. So I know for sure that they really enjoyed that someone is actually using their creation, because I'm a creator myself, so I know how it feels like. Though obviously that's subjective, every person and their own thing, but it's like every project you make is kind of like a baby, for you. Although I'm probably gonna be like a bad father because I keep abandoning my projects. But I'm just like an explorer, you know. I like to explore things and technologies and just teach what I learned. But other than that, I think we're good to go. So there we go. Glad you enjoyed the binding, though I agree that its dump errors are not logged by default. The template had an example of error logging and SDL logging, but it was kind of out of the way. I pushed a new version that has an example of how to set up logging, and now SDL errors are logged as default. By the way, the shader cross branch had the examples in Zig. Oh, it did have an example. Okay, so I didn't notice that part actually. I just noticed that shader cross thing, but the stuff in that branch is incomplete. Also notice, where is it? Also, this is how you destructure tuples. So you can actually destructure tuples in Zig. Did I unmute my mic? Yeah, I did. Okay, so you just do it like this apparently. It's that simple, huh? Okay, that's interesting. Other than that, let's go back into the message. Let me know if there are any other improvements that can be made here. Yeah, sure. Okay. So yeah, the binding is like fresh air compared to C interface. Absolutely enjoyed it. Thanks for your efforts. Please keep going. Alright. So, let's actually check out his what updates he have done actually. SDL3 Zig, because I haven't really checked them up yet. So there's like 1 hour ago. Yeah, so the same thing happened with Div UI. They also like pushed some updates, like when the creator have seen my live stream. So I love the fact that the community is like, honestly, all the bindings I've tried in Zig are so freaking good, bro. It's insane. Like the Vulkan Zig is like the best binding I've ever used. That's for sure. It's like, for example, like in C++ and stuff and other languages, it's so insane. It's like, for example, C or C++, you had to use like multiple libraries just to get like Vulkan set up. Like, for example, you would use Vulk to do that dispatch tables, but like Vulkan Zig already have the dispatch tables made for you. Though Rust, on the other hand, did also a good job with Ash. But honestly, I think I find the Zig one much better maybe. But yeah, they're kind of comparable, but yeah. Anyways, what else? Yeah, and also, like, for example, Vulkan HPP, on the other hand, like the C++ binding, it's so damn slow to compile, and like sometimes the IntelliSense just breaks. In fact, not sometimes, it just breaks. And like your project just slow down to a halt because like the generated thing is just so big. I mean, in Zig it's the same thing, but like it's a different way of compilation. Like in Zig, it does lazy compilation, so you only use what you're, you only pay for what you use basically. As I said, on the other hand, DVUI also fixed a few things that I've mentioned in a live stream, like for example the README. So that was cool. Where is it? Where is it? Yeah, it's like yeah, there you go. So instead of like, I think here there was like something else, but now they fixed it to exe.root module. I'm not sure what they fixed other than, yeah, they also removed that part that kind of confused me about like the custom relib thing. But yeah, and right now you actually have like one snippet that you just copy into Build.zig, which is sick. That's exactly what needs to be done. I'm not sure like why like projects always get the README wrong for some reason. I'm not sure, but yeah. Anyways, I guess let's go back to business. Let's see. So I guess we probably have to update. So what they added, yeah, they added a log.zig example. That's lovely, love that. In fact, maybe we should try to like set up SDL callbacks. Maybe. But I wonder if they changed like the default. Yeah, so the default was, I guess, null, but then they changed it to extras.sdl error SDL log. That's great. Lovely. Love that. And here's the default one. Apparently it's inside of extras. Yeah. So if error, then they just say log category errors log error, and otherwise unknown. That's pretty cool. There's even SDL error SDL message box, so you could like change the callback to that if you want to have a message box like showed up instead of printed into the console. So that's sick. Okay, what else? Is there anything else? Let's see. Critical. Log. Yeah, just login changes. Apparently, that's sick. That's lovely. Alright, so how do you update again? I've never updated the binding. Let's see. I guess probably Zig update or something. No? Let's see. And yeah, I've been working on a lot of stuff, a lot of refactoring and stuff that we'll see in a second. But let's just see what's going on here. Zig update. There's no Zig update here. Weird. Well, I guess then we could probably change the... But you know what? Let's not do that right now because I have some changes here that I've been, you know, dealing with. So let's actually see the refactors and stuff first of all that I've pushed off camera. I'm gonna explain those and then we'll see what we're gonna do next. So GitHub Kodachaku, or just like github.com, right? Let's go ahead and do this. Kodachaku. There you go. SDL Kodachaku. And let's go to... Okay, so I think we left it at the skybox, yeah. So previous live stream, we left it at the skybox and then I've done this off camera. So nothing fancy, just mostly just refactors. So first of all, I abstracted texture and buffer. Right now we have a dedicated buffer.zig function and I just moved a lot of the core functions into it. So because like at some point like the core.zig file was just huge and like it had stuff for textures, buffers and all sorts of stuff. I just kind of extracted that, obviously using... I like helped with or like assisted with AI to do the refactor. But yeah, anyways, so we got the handle, the size, and here core SDL3, blah blah, init, and it just creates a buffer. The init, release the buffer, and here we got some upload requests, upload batch. Okay, so we had this function basically in core.zig, and here we got a convenience wrapper as upload, which basically takes in conti type, data, usage, and it gives you back an upload request, and it just like turns it into slices, bytes essentially. Yeah, so you could use it. Next up we have main.zig. Right now, instead of saying core.load texture png, right now we're saying texture.load png, as you can see, and we're passing core as an address. And now instead of saying this, same thing here. And here instead of saying core.device.release texture, we just say skybox texture.dinit, and then we pass in core. So yeah, and here we just say .handle to give it the raw handle. But yeah. Here in the mesh.zig right now, instead of using the raw buffers, we're using the buffer abstraction. And instead of doing this, we're just saying using buffer, yeah. What else? We just removed the comments there. Okay. Yeah, nothing fancy, it's just like abstraction. And here texture.zig at 2, so we got a handle and a width and a height. And here it checks if the layers is equal to 6, then it gives it a cube, else blah blah, whatever. It takes width, height, format, and layers. Okay. Lloyd PNG here. Lloyd cube map. So and we got like the upload here. Alright, so that's basically it. Nothing fancy. What's next? We removed some unused. Now, I removed the unused functions like from the core.zig because we have, replaced them with the texture abstraction and like buffer abstraction. So we just removed those, nothing fancy. So yeah, next up we got the pipeline and shader abstraction. Okay, so here we have right now a shader and pipeline abstraction. And now, instead of having this whole code in our main .zig, right now we just say shader.init, we give it the core, the file name, and like the how much uniform buffers, etc. And you're good to go. And then you say the var main.var.dns, blah blah blah. Same thing with pipeline. You just say pipeline.init, and then you pass in the vertex shader, the fragment shader, and if you want to change the depth test and stuff like that. So that's sick. The file name skybox.vert, skybox.frag, and yeah, and here the sky pipeline. So try pipeline.init. So it's kind of like similar to this, but we just change the shaders and we change the depth right to false instead of true, because we don't want the skybox to write to the depth buffer. And yeah. Okay, what else we changed here? Yeah. So I think right now, no, wait. I'm not sure what changed here, but yeah, probably where's the frame, like the pipeline stuff? Where's the pipeline stuff? Where is it? Let's see. Bind graphics pipeline, main pipeline.handle. Yeah, that's all. Yeah, cool. Next up, pipeline.zig. Okay, so pipeline.zig only have like a handle to a graphics pipeline. They have a config, which is a shader invert and frag, and depth test equals false by default, and depth right is equal to true. And yeah, init, and we just moved like that stuff into here. That's cool. Here shader.zig just takes in the file name, the sampler count, the uniform buffer count, storage buffer count. Okay. And yeah, that cross-platform, like cross-API shader loading, I put it in shader.zig pretty much. So that's cool. And yeah, nothing fancy again. Other than that, we refactored core. Let's see. Well, we removed all this stuff. Nah, it's just, yeah, it's kind of jumbled up right there. Core.zig. Actually, we removed, yeah, my bad. We removed the pipeline stuff and the shader stuff, right? Since we moved it to pipeline.zig, yeah, that's what happened in here. And yeah, pretty much sick. Next up, refactor core, and finally refactor depth texture. Now we had like a different function for creating depth textures. Now I just removed that one and just instead made the texture.zig function be able to init depth, right, itself. So yeah, again, nothing fancy. There you go. So we just do this instead. Usage, texture usage flags. This is kind of unnecessary, to be honest with you. Anyways, sample count, no multi-sampling, blah blah blah. And here we go. Init depth right now, it just says self.init core blah blah blah, and then it just gives it like the depth 16 norm. We probably want to use more precision there, like 32, but we'll see about that anyways. Create sampler. What else? Yeah. So yeah, nothing fancy, as I said, just a bit of refactoring there. Other than that, I was actually working on something more advanced than that. Off camera though, I haven't completed it just yet. So I was working on adding this staging belt abstraction. Now remember, in the previous live stream, I've actually shown you this build.rs, so like this staging belt in WGPU Rust, and I wanted to make something like it before SDL3 GPU. So I just kind of fed this into the AI and told it to like write a translation for me to SDL3 GPU. Now I had to go through a lot of iterations to fix all the errors and stuff, especially since I'm using like not the raw binding, and you know, WGPU is a bit different than SDL3 GPU. But yeah, and honestly I haven't really understood it fully yet, but this is what we're gonna try to do in this live stream. I think first we're gonna try to maybe rewrite the code that I got, like vibe coded, but yeah, and it actually seems to be working just fine. So this is the staging belt.zig, and what this do is, instead of having like one transfer buffer, like basically before we had an upload batch function, right, which basically kind of like coalesces like multiple data into one transfer buffer, and then it sends them to the GPU, uploads them to the GPU VRAM. And here we have a more advanced, this is kind of like the industry standard of uploading data to the GPU, which is, I believe it's kind of like a ring buffer to some degree. Not really, I guess. But yeah, either way. So what you say is, let me actually show you how I'm using it here. So in main.zig, and here we just set some staging chunk size. So 1 megabyte chunks by default, though if there is need for more, like let's say some high resolution textures, then it actually gonna do it. But it's gonna get rid of it later on, because it's just too big for reusing, but we'll see about that anyways. So now, texture init depth, so, wait, where is it using it? Yeah, actually it's not going to show up here, because in fact we're using it in the init texture.zig. Yeah, I'll see about that. And also I actually allocated the core on the heap, because right now, first of all, we don't need to pass in an address of every single time, and second of all, we make sure that it's stable, because we may want to store that pointer into some child struct, and so we don't want it to be moved, because if it got moved, we're in trouble. But yeah, what else? Yeah, that's it pretty much. It's quite, as you can see from this perspective, like the staging buffer kind of like doesn't exist, but it's actually working under the hood in the core.zig. We'll see about that in a second. Yeah. Right, so let me show you how that works. So here we're just creating a staging belt in the core.zig, right? And what we're doing here, let's see. So as you can see here, I'm allocating self on the heap. And yeah, because as you can see here, the staging belt actually stores like a pointer to, what is it called? Yeah, to the core, and we don't want that moved, so this is why I did that. So as you can see right now, I can just say staging belt.init self, right? So yeah, try window.show. This is why it's kind of not great. In fact, I could probably just remove that part, right? This is why it's not great to like store pointers to, let's say, core in this case, into any other abstraction. And in fact, maybe we could even do that here really. But we'll see about that anyways. And here we just say self.stagingbuild.dinit, nothing fancy, allocator destroy. Okay. Okay, so here in the end function, we acquire fence, so the belt knows when the GPU is done with this frames data. So try self.commandBuffer.submit and acquire fence. So we wait for it, and then we move the active chunks to the closed queue associated with this fence. So try core stagingbuild.finish, and we give it the fence. Cool. Alright, so now then we just release the fence. Next up, and here in the begin frame we actually do the recall. So as long as you're doing the staging belt recall in your begin frame to clear up or clean up unused data, and you do this acquire, submit and acquire fence stuff to actually wait for the data to finish and stuff, you should be good to go. So this is done transparently for you in the core.zig abstraction, so you don't have to bother with that, because otherwise if you forget it, you're just going to leak memory. But yeah, if we couldn't get a texture window minimize, discard the command buffer. Okay, now let's see how texture.zig is using this staging buffer. So here we're acquiring a command buffer, we begin in the copy pass, and then we say try core.stagingbuild.write texture. Then we give it the copy pass, the texture.handle, the width, the height, the depth, and then the raw size time h, which is like the size. So essentially right now what you do is you just request some size, some buffer of certain size from the staging belt, and it just gives you that. And then you could fill it with data, essentially. As you can see, staging slice, and you fill that with data. So it's basically an allocator to some degree, right? So yeah. Copy pass.end, submit and acquire fence, finish, wait for fence, release fence. Now at some point I should probably refactor this to just take a copy pass instead or something like that. Or honestly, instead of doing that, we could just begin the copy pass outside of this and just write the texture directly, assuming that the user have already begun the copy pass. So we could basically like put more uploads into one, like basically do all the uploads in one command buffer. That's what I'm trying to say here. Because right now we're going to be like uploading one PNG, then waiting for it to finish, then uploading another, and so on. So that's kind of slow. But yeah. Next up, what we got here, let's see. Acquire command buffer. Hopefully all this vibe coding wouldn't hit me in the ass later on, but we'll see. So especially that I don't have like render, what is it called? Render, what is it? Oh my god, I forgot about that debugger's name. Render doc, yeah, render doc. Right, texture, copy pass. So yeah, as you can see here, we used to like create a transfer buffer specifically for this and so on, all that crap. Now we just ask for the staging belt to give us that chunk. So that's sick. Alright, so let's go to the next thing, which is the actual staging belt. And I honestly haven't really got into it much. Like most of the time have gone just to try to get this to compile first of all with the AI. And I guess today we'll go through it and understand it together, how it works. But what I understood so far, at least, is that it's kind of like a heap allocator. You just have some active chunks, closed chunks, and free chunks. So the active chunks, I believe, is like the chunks that are currently in flight, meaning they're being used by the GPU currently. The closed chunks, closed chunks I think are chunks maybe that are like complete but still awaiting like GPU upload possibly. And then the free chunks, are like the chunks that we're done with, that were active before but right now they're free, so we could actually use them. Alright, so let's see what's actually happening right here. Let's see. And a chunk is basically just a buffer, a transfer buffer, a size and an offset, and finally a fence. And we use a fence to actually wait, to make sure the CPU waits on the GPU to complete its upload essentially. And can allocate function and allocate. So can allocate would tell you if you can allocate more data of this size into this chunk or not with this particular alignment. So here we're just using align forward. So that makes sense. And here the allocate function just goes ahead and actually do the allocation. So that's cool. And obviously just like advances the offset. So you basically have this 1 megabyte chunks of VRAM, right? And then you keep on filling them like this, like a bump allocator. So yeah, it's kind of like what we had before, but right now it's much more advanced because it could, yeah. Hello, Zero Duckies. Welcome to the live stream. Hello, hello. So we're just trying to understand how the staging belt code that I've vibe coded, inspiring from belt.rs from WGPU. How does it work? And so yeah, that's all we're doing right now, just to give you some context. Okay, let's see. So here init, it just takes in the core and the chunk size. In the dinit, nothing fancy. It just goes through all the chunks and they destroy them, and then it deinitialize or like deallocate that array. Nothing fancy. Next step, destroy chunk. It just like release the transfer buffer, and if there is a fence, it releases that fence. And here the recall. The recall is the one responsible for looking into the current active chunks and seeing if they're finished or not. And if they are finished, we want to put them into the free chunks. And finally, write texture. You give it the copy path, the destination, the size, etc. It tries to allocate some space of this size and alignment, and then it uses the copy path to upload the texture. So allocation.chunk.buffer, allocation.offset, and here we map the transfer buffer. Now allocate map transfer buffer, allocation chunk buffer false. Return mapped allocation.offset 0.size. So here we map it to the CPU, so that we could write data into it, and then we pass the mapped pointer or the mapped slice into the user so they could write into it. And when they write into it, they're going to be writing straight into the GPU buffer, essentially the GPU staging buffer. So here we just say allocation to offset and 0 up to size sig. Now here allocate space. So we try the active chunks. We see if there is some active chunks that we could allocate into, I guess. Yeah, let's see. Or actually, let's just go through this for now. Let's see what we got here. And finally finish. All right, so let's just see what we have here, pretty much. So this is allocate space. It takes in self, size, and alignment. And it gives you back a chunk and an offset. Why an offset though? Doesn't the chunk already have an offset? We'll see about that. Anyway, so we go through all the active chunks first. So this is our first strategy. So chunk can allocate. So if this current chunk, this active chunk can allocate this particular size and alignment, then we just return that. We're done. We found where we're going to allocate our data. So chunk the allocate size and alignment. And then we say self.recall. I'm not sure why it's doing self.recall here actually. I guess we'll see about that later on. Next up, if we couldn't get an active chunk that is compatible with our size and alignment, got stuck vibe coding AVX, learned a lot though. Yeah, that's gotta be a lot of fun. I've never honestly touched SIMD before much, really. Yeah, I should probably make a live stream on that too. Like, honestly, I have a lot in my mind that I want to do live streams on and try learning but yeah. Okay, so if the active chunks failed, we couldn't find one, then we're gonna go to the free pool. So if size is less than or equal to the chunk size, and self.freeChunksItem.len is greater than 0. So you know what we're doing here? So remember that we're allocating chunks in 1 megabyte. But let's say we have some buffer or like texture that needs 1 more than megabyte. Then we can't actually use any of the current free pools, right? Because the only chunks that we currently would have in the free pool would be chunks of 1 megabyte, which is not enough. So we get straight into the third option, into the third allocation strategy, right? But if the allocation is actually like less than 1 megabyte or equal to 1 megabyte or whatever chunk size we have used here, and self.freeChunksItem, and there is some free chunks, right? So it's not empty. Then we try to pop one free chunk from there, and we set the chunk offset to 0. So we kind of like reset it there. Okay, so try self.activeChunks.append. So if we got a free chunk here, oh, actually, if it can't find, oh, well, it's already, you know, it could basically just try to pop some chunk first and then check, maybe. Maybe that wouldn't work. We'll see about that. Anyways, I honestly would probably like just rewrite this whole thing, really, because yeah, probably rewrite this, but we'll see. So self.activeChunks.append. So here we append that free chunk that we found. We append it to the active chunks. We give it the core allocator, okay, and item C. And here ref self.activeChunks.items. Self.activeChunk.item.len -1. So like we basically get the last active chunk, which we just appended here. So append doesn't actually give you that, okay, but is there like some sort of last function instead of doing this weird thing? Anyways, whatever. So we return a chunk, so the reference to the chunk, and the offset would be ref. So here we actually allocate into the chunk and it gives us back the offset. Sick. So ref to allocate size, comma alignment. Next up we create, so basically if we couldn't do this strategy, then we go to the next and third strategy right here, which is to simply, so basically we couldn't recycle any kind of like chunk, so we just create a new chunk now. So cost new size is max self.chunk size, comma size plus alignment. Max. Okay, so basically if the size is much smaller, then we just go with chunk size. Otherwise, if the size is bigger, then we go with the actual size, right? Next up, we create a new transfer buffer. Create transfer buffer, size new size. Okay, back. So create transfer buffer, size new size, usage upload, nothing fancy here. And right now we append this to the active chunks. There we go. And ref active chunks, yeah, kind of like similar to this here. So this could definitely be into its own function. So yeah, this is kind of a rough implementation that I hardly got working using vibe coding. Yeah. So while self.activeChunkItems.len greater than 0. And here the finish function, it gets a fence. So while self.activeChunksItems.len, so while we have some active chunks, we pop the chunk, we nmap the buffer. Okay, so I guess this is maybe what happens at the end of the frame, right? We start actually maybe uploading that stuff or something. Wait, where is this being called here? Yeah, it's at the end of the frame. Move the active chunks to the closed queue associated with this fence, right? And then we basically use this fence to wait for the upload of all those chunks to finish at once, right? So we use one fence for all the current frame uploads. Yeah, so that's actually pretty clever, really. It's like a naive solution would be to just like use one fence for every single chunk. But yeah, try self.closeChunks.append self.core.allocator, C. Yep, nothing fancy. Yeah, honestly, I think I'm gonna probably rewrite this. Or should we just use it? Yeah, I think, let's just use it, I guess. I'll just use it. Although it could probably be rewritten much. What do you guys think? Should we rewrite it? Well, one thing for sure, we should just, this is deprecated, we should just use ArrayList. Yeah, so like I have always problems with the AI using ArrayList thinking it's managed by default, which it was in previous Zig versions, but it's no longer the case. But yeah, anyways, next up, I think, yeah, we could just commit this maybe. And I should refactor now the buffer abstraction to use the new staging belt, because I only refactored the texture, hardly did that right first. And yeah, let's just put all that stuff there. And this is the .cache. Let's actually add this .cache into our git ignore really quickly. This is from the zigzag tool that I'm using. So this is the one that I covered in a video pretty much. So I'm gonna show you how this would work out in a second. But yeah, all right. So .cache, right? .cache, there we go. And hopefully that would remove this. There we go, cool, love that. And also report.md. And we're good. So we're gonna stage all these changes, I think. And this is the staging belt commit. Sync changes, and I'm gonna basically push it. And obviously it's still working just as before. Actually, I would love to work on async textures, like async assets, because you can see that the skybox right now takes a long time to load. But we'll see. Alright, so yeah. Now let's actually try to do the buffer stuff to use the staging belt. But for that, what I'm gonna do right now is I'm going to use zigzag. And I'm gonna run it on SRC. And it would generate a report for me, which is basically all the code that I have currently in my code base. So right now we have like around 1,000 lines of code. Okay, and let's see. Let's go to Gemini. Well, I already have Gemini here, okay. And let's paste all of this to give us the initial context of our project and to start in a new slate. And honestly, only have, unfortunately, a limit up to 1,000 lines at least of free version. So we're gonna look for this part right here, copy paste upload to texture. Right, texture. So I guess, yeah, up to 1,000 lines apparently. So let's just copy the last lines and let's just upload this. And there you go. And let's also give it like the complete, the completion code, and let's go. Alright, so let's actually read this even and see what it's going to tell us. This report covers a Zig-based 3D render utilizing the SDL3 GPU API. The architecture emphasizes efficient memory management through a staging belt system and a clean abstraction layer over GPU resources. Because like the staging belt currently is the most advanced thing that we have in the project right now. So the code base is organized into a core engine context, core.zig, and modular wrappers from graphics primitives. The engine follows a modern bindless light approach where resources are managed via staging belt, handles CPU to GPU data transfers without blocking the pipeline, buffer batching. Oh yeah, one other thing that I've forgot to mention is the fact that we're not waiting on the fences here. I think we're just checking for them to finish or something. Oh, I actually haven't looked into recall function here, which is the one, I'm sorry, that's doing this job. Okay, actually let's go through this really quickly. So we got I is equal to 0, and we're going through all the closed chunks, which basically were uploaded to the GPU, or at least currently uploading. We grab the chunk, and if the chunk got a fence, I'm not sure why we're checking if the chunk got a fence, but we'll see anyways. If self.core.device, so here we don't wait for the fence. We check the status of the fence. Is it done or not? Because there's like probably a blocking option. So I think so. I mean, I haven't really dealt much with SDL3 GPU fences. I only used Vulkan fences, but it should be pretty much the same thing. Yeah, there you go. So there's wait for fences, which is blocking, and there's query fences, which is not blocking. So this is kind of like the pull-in version. And so essentially here, this recall is being called every beginning of a frame, I think. Yeah, probably beginning of every frame. Actually, even before the allocate space function. Oh, really? Which? Yeah, we're calling it in the beginning of the frame to basically recall any kind of like closed chunks that are free to, so we could like allocate to them essentially. And we're also recalling after trying the active chunks, so just before we check the free pool. I see, so that's cool. That's cool. Anyways, so we're query defense. And what this returns exactly? Check the status of the fence. I guess it would probably say if it's finished or not, right? Swap remove. Removes the element at specified index and returns it. The empty slot is filled from the end of the list. Okay, so this is a faster remove function in the like array list, pretty much. So yeah, if finish.fence, old fence, then we release that current fence. And we say finish.fence is equal to null. Wait. So we removed the fence. And then we release that fence. And then we set it to null. And then only keep chunks that match our standard size in the free pool to avoid keeping jumbo chunks forever. By jumbo, they probably mean those chunks that are bigger than the chunk size, which is like 1 megabyte that I've talked about before. So if finished size is equal to self.chunk size, so as you can see, if this is like a standard chunk size, then we give it back to the free chunks pool, right? So self.free chunks.append. Honestly, you know, I don't have that much experience in allocators, and this is a lot of fun, to be honest. I should probably make some allocators in Zig at some point in streams, you know, and try to learn that. But yeah, let me know, guys, if you're interested into that. But yeah. Anyways, append, okay. Else, if it's just like non-standard chunk size, we just release that transfer buffer. We just remove it. And then here we continue to the next. Why continue? I mean, I think this is probably useless. I could be wrong. Yeah, it's probably useless. Wait, no, actually no. Here there is I plus equal 1. And here it's continuing to the next iteration. Why? Okay, so basically if this chunk have a fence and this fence is finished Then we're going to continue to the next iteration without advancing. So I guess maybe we're going to try the same fence again. Is that right? I don't think that's a good... Okay, let me see something here, but we'll see about that. Anyways, so buffer batching minimizes the command buffer submissions during asset loading. And here this supports per VMSL and DXL, okay, whichever. And here the staging belt. This is the heart of the engine's memory efficiency. Instead of creating a new transfer buffer for every upload, it uses a ring buffer of chunks. So the active chunks currently receiving CPU data. Okay, so this is the active chunks. And the closed chunks submitted to GPU waiting for a fence to signal completion. And the free chunks, recycled buffers ready for new data. Logic uses recall to query GPU fences, automatically reclaiming memory once the GPU is finished with the frame. And the core context structs acts as the central hub. Hello, Theo Paris. Hello. Hello, P2P Sec. I just noticed your comment. And BMQW, welcome to the live stream. These are very hard shit. Yeah, so I was working on a little bit advanced allocator kind of for like, not allocator, like basically it's for uploading GP like data into VRAM efficiently. It's inspired from WGPU. In fact, I vibe coded it, so I basically gave the AI this WGPU build.rs in the util here. I gave it this, and then I give it my code, and then I had to go through a lot of iterations to fix the bugs. And yeah, obviously off camera, and I got this code. And right now we're just trying to what is it called? To understand how this works. And so far, I think I understand how it works to some degree. But yeah, it's a lot of fun. I don't have that much experience, as I said, on allocators, but this is a lot of fun. So does using AI as a helper or teacher for coding works well? Asking for... Yeah, definitely. And also for refactoring. Although sometimes you can get weird, like... You should at least, like, know what you're kind of doing. It's like... So basically, to use this AI stuff like efficiently, you have to be coding like for years manually first, and then use helpers essentially. So yeah, but like if you just go straight into just like doing AI, then you're probably not gonna do much. Yeah, because yeah, exactly, and you also have to be good at debugging, right? And also another thing is that you need to be using what is it called? Source control. Yeah, source control. Otherwise, you're gonna be in a big problem. So basically, if you had some problematic commit, you just discard it and try again. It throws off the track. Yeah, that's for sure. But yeah, mostly it's quite useful if you know what you're doing. Yeah. Anyways, let's go back to what we were doing. But pretty much this is just a chill stream. You can guys ask me questions, like suggest me ideas. We could discuss some topics. Feel free. This is kind of like just like the side thing that we're doing. We're working on a library to abstract SDL3 GPU stuff. But yeah. Alright, so let's see. Acquire textures for the current frame. And shader backend detection automatically maps the environment to the correct shader folder. Frame lifecycle. The frame substruct enforces the strict begin-end pattern. Ensuring command buffers are submitted and fencers are tracked. And the upload batch function in buffer.zig is a notable optimization. Now, we did have this upload batch, I believe, in buffers and maybe also textures. Though maybe actually we didn't have it for textures, I think. But yeah, this was an optimization because we didn't have the staging belt. But right now, since we have a staging belt, we don't need this upload batch anymore. We could just do upload directly. So we're going to work on that. So calculate the total size for multiple requests. So basically beforehand, before we had a staging buffer, we were just like batching multiple uploads into one transfer buffer. But the problem with that though is that first of all you need to know all the stuff that you want to upload beforehand, so you could basically allocate the correct size of transfer buffer, and like you can't do this over multiple uploads and stuff. But using the staging belt, you just ask it for a buffer of certain size and alignment and you just do it, so yeah. Maps memory wants to copy all data and submits the single copy pass, reducing driver overhead. Another thing also is that this staging belt have a little, not problem, but like just inefficiency, which is about, I think, mapping transfer buffers. So instead of like just every time you upload some stuff, I think like you try to map it. I think you probably should like persistently map all the current transfer buffers and just use them. Yeah. But we'll see. Anyways, ensure compatibility across different GPU architectures, resource recycling, reduce the frequency of expensive create buffer calls, FPS stability, euler-based camera prevents floating point drift, common NPR quaternion rotation, safety or defer usage. And okay, so recommendations and observations. Skybox optimization in main.zig, you're manually zeroing the translation part of the view matrix. This is correct way to keep the skybox centered in the camera. And depth stencil. The pipeline currently uses depth 16U norm. For larger scenes, you might consider depth 32 float to prevent Z fighting at long distances. And finally, staging belt completion. The right texture function in staging belt.zig appears to be truncated at the end of the file. Yeah, this is where we actually give it that. Thanks for providing the remaining modules with the full implementation of the staging belt. Your renderer now has a robust foundation for modern asset streaming and memory management. Yeah, staging belt is also used for streaming buffers into the GPU. So the completed GPU staging belt and texture models illustrate a highly efficient way to move data from your CPU to the GPU without causing the stuttering often seen in simpler implementations. So the life cycle of a texture upload. When you call Lloyd PNG or Lloyd QMap, the following sequence occurs. The CPU preparation, SDL3 loads the PNG, converts it to a standard RGB A32 format. We should probably make an asset loader too. So like if you try to load the same PNG twice, you're just going to get the same thing. But yeah. Staging request. The texture module asks the staging belt for a slice of memory in the transfer buffer, and then the jumbo fallback. It allocates space. If a texture is larger than your default 1 MB chunk, the belt automatically creates a jumbo chunk to accommodate it, ensuring you aren't limited by your default settings. Next up, we got GPU copy. A copy pass is recorded telling the GPU to move data from the transfer buffer to the final optimized texture handle. Yeah. And fence synchronization. In Lloyd PNG, explicitly wait for the fence. This is a blocking Lloyd. Yeah. For a more advanced version, you could allow the engine to continue and check the fence later to support asynchronous background loading. Yep, because right now, if you notice here, when we run the application, it takes quite some time to actually load all the assets, all the skybox assets especially. But yeah. So yeah, we're definitely gonna like benefit from async loading. Other than that, the standard size optimization. You have a smart check. This is excellent practice. It prevents memory fragmentation. By only recycling chunks of a predictable size, jumbo chunks like those used for 4K textures are released immediately after use, so they don't sit in the pool wasting RAM. Next up, vertex attribute mapping. Your vertex.zig uses offset off. This is significantly safer than hard-coding numbers, as it ensures your GPU input layout stays perfectly in sync with your zig struct, even if you add more fields like normals or vertex colors later. And then finally, QMap handling. The Lloyd QMap implementation is clean by iterating through 6-phase and using the layer property of SDL3 GPU texture region. You've correctly implemented the hardware level QMap layout required for skybox rendering. So yeah, implementation table. meshes, we apply the batch, and staging belt write texture for textures, uniforms, inline, dynamic frame relative, batch transfer 6 layers. And final architecture summary. Your project is currently a state-of-the-art SDL3 implementation by using the GPU API directly instead of the old 2D renderer. You have full control over the graphics pipeline, the separation between core.zig context and staging belt.memory, and specialized resource types, texture, and meshes. It follows professional engine architecture patterns similar to WGPU or Vulkan. WGPU kind of picked up on WGPU, weird. Okay, and Vulkan-based engines. Alright, so that was like the overview of what we've done so far using AI, as you can see. But yeah. Alright, so what we're gonna do now, let's see. Well, first of all, instead of this, I think we could just remove this in managed part. And we could probably just say .empty. Can we do that? Yeah, we can do that. Okay, sick. Next step, what else? Yeah, can I actually move this core? So like we would just, yeah, I think, is it better to remove core pointer from staging belt? Pass it to every function. Is often the most ergonomic. Here's how I would wait to change for a specific project when you keep the pointer. Okay, fine, whatever. Alright, what we gonna do next? What we gonna work on next? Actually, let's just remove this, fine, whatever. So, can we try to update now? Let's actually update SDL. SDL binding. SDL bell.zig or bell.zig's on. How to update zig dependencies. Yeah, that doesn't seem like the case. So now let's come here, I guess, maybe, and let's try this instead. Hello, Mucho. Welcome back to the live stream. Okay, so this is how you update, apparently. So that's cool. Now, can we try to build again? That didn't seem like it changed much, I guess, no? Yeah. Interesting. Let's go back to the staging belt. Fine. Let's just remove this anyways.
Don't know why I removed it, whichever. Next step, what we're gonna do is we're gonna go, yeah, I wanted to do the same with buffer.zig. Okay, let's go to Google Gemini. Can refactor buffer.zig to use the staging buffer. Other than that, let's also go back to the core, and I believe we had like a destructuring thing. Where is that? So here, what you could do here is you just say swap chain, I guess width and height. Isn't that the case? Really? That's strange. Doesn't work like that. Oh, here we go, the Zig documentation. I guess without the const apparently. Huh? Oh, this is actually master. Nah, that, what the heck? Yeah, that doesn't seem to work. I'm not sure why. Probably have something wrong here. But anyways, whichever. So let's see what Gemini have said here. Is it pro? No, just free version. I had the plus version at some point, but it just got expired. So yeah. Why picking Gemini instead of ChatGPT? Because Gemini have a huge context. First of all. Second of all, it's quite fast. And also it doesn't expand all the text like this. So like ChatGPT choke on such huge text. And I think ChatGPT is probably quite limited. Yeah. Especially the free, although I actually have ChatGPT Plus, but yeah. Can you refactor? Alright, so let's just try to use this. Ah yes, I see now. It does mess up in big message. You tried Anthropic solution. Anthropic, what is it called? Claude, right? Claude free version is quite limited. So, and like their paid version, I don't think they have a plus version either. So every month you have to pay quite a little bit for it. But yeah. And yeah. Alright, so let's just try to use this. Fine. Let's go to, what is it? Buffer, yeah. Buffer. And actually, instead of this, we could just say, in Gemini, on the bottom right, there is fast, and you get a few prompts daily for, I mean, I had the plus version, and the pro model never gave me something like quite interesting, to be honest with you. It just like overthinks, that's all. And in fact, that's why I don't even like really need that much to, what is it called? Man, I zone out to upgrade, but yeah. So the free version is fine. Yeah, Pro is worse, pretty much. Like how ChatGPT does. I hear people are installing ChatGPT as a protest. ChatGPT, I have mixed opinions on it. I mean, ChatGPT is quite good at presenting things, presenting topics, and like explaining things. That's for sure. Like especially if stuff is about, it's kind of like more human to some degree, while the other LLMs is more professional. If that's how I would say. Yeah, good at talking. Yeah, that's what I've found ChatGPT is pretty good at. It's pretty good at talking. Actually, they have advantage given they were the first movers. Yeah, no idea, sorry. What are people protesting about ChatGPT? I heard people talk to it like human. Yeah, it's pretty good at like talking like a human, you know, so. And pretty good at presenting things. It took me some time to actually like, you know, adapt to Gemini. But honestly, like ChatGPT 4 was actually way better at kind of like being human. And in fact, it was even, it kind of like whatever you do, it kind of just like, it's kind of like delusional. It just tells you like you're good, like it just pumps your ego and stuff. So people really love that, you know. That's why in the latest ChatGPT they kind of tuned it down a bit. But yeah, Grok on the other hand, I found it to be more unfiltered. How about DeepSeek Coder? Is it any good or trash? I've never used DeepSeek, so I have no clue. Never used DeepSeek. So the thing is, here we don't really need any more upload batch since we have a staging buffer. Gemini has a good memory for previous questions, so I stick with it. Yeah, Gemini has a huge context window, so it can remember like all your code base and like all the conversation easily. So yeah, from sync to async. Yeah, I have no clue about Anthropic. If anybody's like, you know, experienced in Anthropic, then please share with us your thoughts about it. You will need to update your mesh.zig to pass the copy pass down. Here's how the init would change. And like, how good is the Anthropic Pro model? So, because I never tried the Pro version. I'd probably try it maybe next month. Yeah, I'll probably try next month. Actually, I'm sick of ChatGPT. Produced shit code. I'm thinking to try an Anthropic model for once. Yeah, ChatGPT is not the best for coding, to be honest. Never tried to code in specific AIs like Claude or others. Yeah. One thing that I noticed from my very limited like Claude interaction in the previous live stream is that it's kind of like straightforward. It just focuses on, you know, writing code and get it done. It doesn't ask you a lot of questions and stuff. That's what I know. So it's mostly just like a coding thing. You know, you can't. Yeah. Does anyone know any AI which gives dark joke or illegal joke? I would say Grok is the closest. Yeah, Grok is the closest to that I found. It's pretty interesting. I want to use Duck AI from DuckDuckGo for privacy, but it has a success rate of like 5% of even making sense. You could also like, you know, roll your own AI model locally. And you could go with like an unfiltered model. though it's not gonna be even close to the current LLMs that we have. But yeah, Grok is already raised. Yeah, I wish Grok had like, you know, it could do voice calls, kind of like Gemini. Yeah, it would have been so fun. Just want a version of ChatGPT who speaks with me without filter. Yeah, you wouldn't find that because it just like have a lot of problems with, you know, legality and stuff. But yeah. Note on life cycle. Since now you must ensure. But it's kind of weird that it's mapping the transfer buffer. What? I mean, it should be mapped by the staging buffer. But wait, where it's even getting like the... Oh, it's getting it from the allocate. What the heck, bro? Okay. Bro, what? I mean, come on, bro. Oh, it actually doesn't map them. Alright. I thought it would... Wait, what is this? Oh, it was, I guess, doing it for right texture, huh? Whichever. Anyways, my bad. My bad. Doesn't already... No. So just copy this part. So as you can see right now, we don't need to handle like batch uploads anymore because, you know, the staging belt is already doing the upload batching for you. So you just to simply create with data. And as you can see, our buffer.zig is way simpler now. Actually, the only useful thing I want from AI is to fill forms for me. It's such a pain in the ass filling the same details for different signed documents. Yeah, also Vulkan forms. Yeah. Anyways. Alright, so that's good. Now I'm gonna tell it to refactor. Now refactor mesh.zig. Bro, other indices omitted, come on. Gen whole file. I wonder if there's like a way to, like, you know, Gemini would just give you some sort of like a diff and then you would just upload it, like apply it using one command. Maybe I should some vibe code some tool for that stuff. So right now we already have zigzag, which was actually suggested by someone in my previous stream, which is its creator, right? So you would just do this, and as you can see here, it just gives you the whole code in one file, and then you can just copy paste it into Gemini, which is really useful for providing initial context about your project. But now we probably need some tool to do that, git diffs, instead of like copying the whole file every time. Setting up Vulkan structure is like writing a form. Yeah, pretty much. So let's see. Where's the mesh.zig here? I don't know why I feel breathless while talking in the stream, to be honest. It's annoying. Anyways, self.init. Should probably start doing some streams where I don't talk. Let's see. Wait, what the heck is happening here? You know what I'm gonna do? Is I'm just gonna copy this and update its memory. Yes, I do. I mean, the window is open, so. Or maybe I'm just not used to like talking too much. Okay. Alright, so as you can see here, it's... Wait, what happened there? Yeah, it's a bit better when you like refresh its memory by uploading the file that you want to target next. So like the first upload of the whole project is just kind of like a bit of overview context, you know? But then every time I want to change some file, you have to like update it. But yeah, alright, so let's try now. Whoops, zig build run. So I have this command right here right now that it basically redirects the airstream into std out, and then I copy it using Wayland, so WL copy, and then I just paste it. Oh yeah. So let's tell it to refactor main.zig2. Man, I hate this. It keeps on messing up with the array lists because it got changed in the latest SIG version. My god. Let's go to mesh.zig now, and let's come here. Yeah, again, problem. My god. Honestly, I should probably like move this vertices and stuff to another structure or something, like to another file or whichever. Another thing that is useful with AI is that you should have like small files. But well, so we have some other error now. Yeah, fucked up. Leave my OBJ function alone. Bruh. I mean, I think I should just like update the init function anyways. That was insane. So just like instead of upload batch, yeah, I think we already have, yeah, we only have it here anyway, so yeah. Okay. Yeah, we still need to pass in the copy pass. So, yeah. Can't we just like put like a copy pass in the core.zig in fact? Maybe we'll see. Goodbye, BMQ. Okay, and there we go. We refactored buffer.zig to use the staging buffer now. Okay, cool. Okay, so apparently it's not a great idea. It's considered dangerous and bad practice. The one pass at a time rule. An SDL3 GPU can generally only have one pass active on a command buffer at any given time. If core owns a copy pass and you accidentally call a function that tries to start a render pass, or another copy pass, the application would crash or trigger a validation error. Anyways, so I think I'll just like read it silently. Yeah, I see. I see. Okay, upload context. In fact, this is probably what we should do next. Yeah, that would really help. So we just updated SDL3 dependency, we refactored buffer to use the staging belt. And here we're using it again here. So like we're just creating a command buffer, beginning a copy pass, then loading a PNG, loading the cube map. And then, wait. Oh, actually one other thing that I want to do is instead, like currently the load PNG, load cube map actually create their own pass. So I'm not sure how this even works here. Oh, because it's like acquiring a command buffer and stuff. Yeah, I see. Okay, so can we actually refactor that really quickly? Refactor texture.zig to use the past copy pass. In fact, does it even need like the copy pass to actually do its job? Or like, can you just begin it? No, because it contains the actual data. Sorry, the functions, the methods. But honestly, I think like if we were just using like raw SDL, I think we wouldn't have to pass it. We could just like begin and end, and maybe, I'm not sure. Anyways, whatever. So instead of like starting a new command buffer just for one PNG, you know, we just use the past copy pass. So that's cool. Let's just grab this and put it in texture.zig. And we should be good to go now, I guess. Ah, yes, my bad. I forgot about that. Let's go to main.zig. Yeah, here. Okay, right now we're using one copy pass and for uploading all the data. Now, let's just remove all this comments, annoying stuff. Okay. Checked your older videos yesterday. Pretty funny to hear a voice so different in your Roblox era. Yeah, I was like young at that point. Like I was 13 years old when I, like my first videos. Like I was eight years. Yeah, it's been 8 years now. So you could like pretty much see my whole evolution in my YouTube channel. Yeah. If I knew what was like waiting for me in terms of like Vulkan and stuff back then, I probably would never start. But yeah. So that's interesting. Alright, so I think right now we're gonna work on async, and by work on I mean vibe code. I'm not sure if like you would be able to, because like there was I think a new API for SDL async stuff, but we'll see. Anyways, let's just stage all the changes right now, and here we just basically added staging build, right? Or what? No, we just like refactored refactor other abstractions, refactor everything, or like, man, come on. Buffer to use staging build, and texture to use existing copy pass. So yeah, sick, love that. Sync the changes, okay, we're good. So yeah, let's try to work on, can we work on, or like, actually let's ask the AI, what should we work on next? So as you can see, using this library right now, you could just say core.init, window size. I should probably make some core function to help with this part. And also same thing with this upload command buffer and copy pass stuff, maybe. And like you just say Lloyd PNG, you give it the path and the copy pass. And Lloyd cube map, and you're done. Init obj, init cube. So it's pretty simple. You still have like full control over what's happening, but oh my, it's way better than like raw code. But yeah, got textures, cube maps, and complex obj meshes all flowing through a single submission. Should we try to make you like implement Div UI backend? I'm not sure if that's even like possible. So this is the whole SDL3 GPU backend. I wonder, like, using our library, how this code would look like. Actually, we could also maybe, you know, like, inspire from this code for our own library too. Yeah. Where I was, my god. Oh yeah, force Gemini, there we go. You can tweak camera speed, light position, okay. Kodotaku UI. Exactly. Should we really try to work on, like, nah. Like, make our own UI? That would be a waste. Should definitely try to use the UI. I'm just not sure yet how we would integrate it with the Gotcha binding. Like, I don't know. Anyways, we'll see about that. Anyway. I'm really scared of, like, the lighting code right now. It's such a, like, what is it called? Such a huge rabbit hole. Debug UI medium high, better workflow. Like, I'm just not, like, focusing much on shaders right here. I'm just focusing on, like, reducing the boilerplate code of the CPU code pretty much. Though, is there, like, Slang libraries already? Yeah, PBR sounds like a whole separate... Yeah, I have never touched that, to be honest with you. The Slang shading language. Because, like, I wonder if we use, like, Slang, is there, like, already some ecosystem around it? Like, let's say some libraries that already implement PBR and so on. You know, hacking the system. The Slang shading language. Yeah, do they have, like, a package manager by any chance? They already, I think, have neural graphics and stuff for that, maybe. I mean, let's ask ChatGPT, I guess. Does Slang have a library for implementing PBR? Oh, wait. Oh my. But I wonder how it, like, handles multiple APIs, like SDL, etc. Like, the changes between, the differences between them. So there's examples here, apparently. And is there PBR? Oops. Bruh. PBR. No, I don't see PBR here. There is a model viewer. Triangle. Wait, Slang graphics. The implement cover, common PBR models like. What's Slang about? I have heard about it a lot recently, but not before. Is it new? I only have experience with... I've never used it either myself, but I feel like it's a more established language for shaders, because, like, GLSL, HLSL, and all the current language that we have is a bit like just like duct tape, you know. It just kind of works for now. but there's not much about like, you know, implementing higher level stuff like interfaces, kind of like classes, etc., and just making things more reusable. So to allow for, let's say, for example, libraries, kind of like Zig libraries, Rust libraries, etc., like a package manager and so on. I'm not sure. I'm just actually like right now seeing if it does that or not, because if it does, we can try to use Slang and we would benefit from the ecosystem, hopefully, so we don't have to like implement all the shaders ourselves. So yeah, these supports. File core. Okay, GitHub file core. A JavaScript library. No. There you go. And where are the PBR stuff, I guess? Yeah, there is some Slang stuff here in materials, PBRT. Yeah, we should actually, by the way, make a materials struct already. Because right now, like the pipelines and textures and so on. I kind of see Slang to GLs as I see WGPU to graphics API. Seems like a more general purpose and higher level alternative. Exactly, yeah. Exactly. Roughness. Should we try to use it? But honestly, you know, let's just stick to the current shaders that we have from the examples for now. Yeah, let's just stick to those for now. But we'll definitely check this out later on. Okay. I was wishing for like, you know, some sort of like, let's say PBR Slang library that you just like import into your project and you just use it, kind of. Okay. I mean, we could just copy the shader actually. Look at that. It even have generics, as you can see, and interfaces. So that's something. Okay. And it kind of looks like HLSL to some degree here. Anyways, let's just go back to business, I guess, for now. Alright, so what we were working on, let's see, dynamic uniform buffers in the build. What should we work on? Yeah, as I said, let's work on async. Or the upload stuff, maybe. Can you implement upload? An upload helper. Let's see. Tell the build that fence tracks the current chunks. I mean, sure. begin and an end. Yeah, it seems to be working great. So right now, instead of creating like a copy pass and all sorts of things, you just like say, where is it? There you go. You just say upload.begin, and then you just say load.png upload.copy pass, and then finally you just say upload.end, right? Where's upload.end? Here we go. Now, can we implement async loading? Or should we work on an asset loader first? Okay, highlights the refactor. Yeah, so we're gonna make an asset loader first. Then maybe we could work on like hot, like swapping, I think, or hot reloading, yeah. And stuff like async stuff. I wonder if we could make use of async IO. I don't think, no. We'll just use like probably the SDL functions for asynchronous stuff. But we'll see. So now what we're gonna do, let's just add this. Upload helper, commit and sync. And now let's see what we got. It's like trying to build a high-speed rail without laying the tracks. You'll end up with a mess of std thread handles and race conditions scattered across main.zig. Yeah. Just for correctness, of course, I meant the web GPU spec and not the Rust implementation of it, which the devs called WGPU. Did they really have to choose the most confusing name? Yeah, I see what you mean. Well, abstraction first. Uniform interface. Whether you load a texture from disk or procedural math from memory, the rest of your engine shouldn't care. You need a single place to track which is currently loading, ready, or failed. Yeah. Gotcha. Gotcha. Even before we touch threads, we refactor the logic to use this manager, the same version. This will still block, but it puts the infrastructure in place. Yes, implement whole asset manager. And let's see. I mean, let's see if this works first of all. So this is asset manager.zig. Well, a search manager, right? Rename. And let's go with asset manager. Let's paste all this code here. And let's see. Integration in main.zig now becomes significantly cleaner. Okay. refactor this. Well, Lloyd mesh obj. As you can see, try assets.lloyd mesh obj. Where's assets? Asset manager. Asset manager.init. Okay. Let's see if this works. Nah, there's definitely an error. Oh, I guess it's running already. Would it work? Yes, it does. What the heck, bro? That's insane. The Rust Vulkan streams were 6 months ago. Whoa, it does not feel like it was that long ago. Yeah, time passes really quickly. Alright, so we got an asset manager. I kind of hate how it keeps on making this struct like this. We could just remove this. And remove this. And in main.zig, we're gonna go up there and remove this. Sick. Alright, so let's see what the heck you have done for this asset manager. So asset handle is a U32. We got some registries, so array list in managed texture and texture paths, which is a string hash map in managed. String hash map. So basically a path like maps to an asset handle, which is a U32. And here we like store the actual textures themselves, the texture handles and the meshes. Yeah. So, all right. Now hold on a second. I'm gonna take a little break and come back. Okay, I'm back. Alright, so let's continue where we left off. Okay, so we had generated this asset manager. So let's see how it works. Okay, so nothing fancy here. The init, blah blah. Lloyd texture, so it takes in an upload. Oh, it's sort of like to use that abstraction, interesting. Since it's using that abstraction, maybe we could like, in fact, make Lloyd PNG takes in and upload directly. Actually, no need. I mean, we're just needing the copy pass there, so yeah. Anyways, but why it's taking a whole upload then if it only needs the copy pass? Yeah, we could definitely just take a copy pass instead there, but anyways. So here it checks if this path already exists. If it already exists, then it just gives it the handle that it's associated with. Otherwise, it tries to load the PNG. Cool, with that path and upload. Copy path, right? And here we get the handle. And the handle is just like the textures items.len. Wait a second. I mean, this is like basically assuming that we're probably not gonna unload any texture, right? Or like resource. I mean, maybe. Anyway, let's see. So here we say self.textures append the texture, and then we add it to the texture pass hash map. Right, and here we actually dupe the path. Yeah, I see. Is that dupe path like gets de-inited or no? De-init. Maybe not. I mean, if it was problematic, then like it would actually error out. Like if it was leaked, it would error out. So maybe the hash map actually already de-init the key, possibly. But yeah, and then Lloyd the cube map. Okay, and if texture pass dot get name. Okay, here, so the cube map, since we have multiple paths, it just used some sort of name instead of a path. Interesting. Lloyd cube map. Right, nothing fancy, much, yeah. And here again, you grab the name, but wait. What? It's getting the data here. I mean, I see. We should probably just get a path here instead, maybe. Oh, but like it's doing it because right now we're just relying on, what is it? Relying on embed file, yeah. But yeah, nothing fancy, seems like. Yeah, that's pretty simple stuff, nothing crazy. And let's go back to main.zig here. And as you can see, we just create an asset manager, then we use it to Lloyd textures, Lloyd cube maps, etc. That's sick. Hello, Overdue RG. I've seen your name before. I think you were in one of my streams, right? Hello. Welcome to the stream. Oh yeah, my Discord. What's your name on Discord? Is it like the same name? Because like, yeah, the name feels familiar, but I just don't remember where I see yeah. Overdue RG. Yeah, I see. Cute profile pic, by the way. There we go. Okay. So what we're gonna do now, I think maybe we should start working on materials. Actually, no, let's implement. Hello, Enzi. Welcome to livestream. The creator of Zigzag. Yeah, I'm actually using it. Right, I'm actually using it. I started off by using it here. Right, by just like starting off a new Gemini session and just providing it the context of my project. Though, while you're here, can you please implement like basically a Gemini here can only pass in like have a limit of 1000 lines, so it should be able to like split it into multiple reports essentially, and basically you kind of like give it, let's say, some sort of like line count, like into how much you can split it essentially. That would be cool, but right now I'm just doing it manually. But yeah, because I haven't actually noticed that, because like the project was under 1000 lines of code, so it was fine. No, but yeah. All right, so okay, let's continue. What we're doing again, the sky pipeline, draw a skybox. Okay, so what should we work? Yeah, as I said, let's work on how we're gonna implement, how I'll implement the async stuff, async part. Nah, I don't think that's necessary. Yeah, I don't think that's necessary, maybe. So it's trying to use like multi-threading. But the thing is about SDL, it added like an async API. So async IO. It generates a JSON file with a specified path. Only downside is it only works with folders as of right now. Definitely add. I see. Can't we just use SDL3 new async? Is it new, right? Mic mute button. I don't have a mic mute. I have like a USB mic. So it's like I don't have a headset on. Yeah, updating the asset manager needs a STD thread in a way. I did in mute, right? Yes. I keep on being paranoid. Like the manager needs an STD thread in a way to communicate back and forth. We could also use our threaded channel queue that we've implemented in the video player videos, but I don't think we need it. If we can use this async IO of SDL, that would be amazing, because we're gonna have actual async instead of just like a thread. Can't wait for Zig's async awaiting 0.16. Yeah, that would be interesting. And welcome to stream ZFBX. Since we're using the stage build, we have a slight complication. We can't write to the builds from a background thread, while the main thread might be using it for something else. Yeah, we don't need even a background thread if we use, I think, SDL async. So let's see what it's gonna say. You're absolutely right. So you're already using SDL3. Leveraging SDL async IO is the most modern way to do this. It's cleaner than managing your own raw STD thread. So as you can see, the AI would have gave us like a over-engineered solution using multiple threads. Since I know that SDL3 have actually async, I actually have never tried it before. but I kind of know what it's about, so yeah. But yeah, let's see what it's gonna do here, because SDL handles the heavy lifting like IO rearing. However, there's one nuance to keep in mind: only handles the loading from disk part. To make this work in your engine, we still need a two-step handshake, because the GPU won't let a background thread talk to it directly. Disk to RAM, SDL3 async. SDL3 loads the file bytes into a buffer in the background. Oh yeah, I missed the mark actually. So this would only, let us do the file loading part asynchronously, not the GPU uploading part. But I'm not sure like which one is taking much more time. Is it like the actual loading, or I wonder. But I guess we'll see. So yeah, once SDL3 says I'm done loading, the main thread takes those bytes, parses them, and pushes them to the staging belt. Okay, SDL3 async IOQ. But I wonder if like our binding actually have support for this already or not. And then you could use like SDL load file async. And then you kind of have like gonna be pulling for the results every frame. Oh yeah. Oh, SDL3 actually uses IUU ring. No mutex, start the task and check the result. 0 copies. Parsing. To get the bytes. But would it at least wait? What do you think? Should we go straight for? Should we go straight for what is it called? Straight for multi-threading, or just try async first? But yeah, let's see first of all if this binding even supports this, in fact. So let's say, for example, STD. Well, no, SDL3. No, where's SDL? Oh, we don't have SDL here. What? Well, we could get it. Oh, actually, no. Core SDL3. Core. There you go. There is async IO. And there's Q and stuff. So, yeah, that would be cool. But wait, we're using Lloyd PNG. So I'm not sure how it would exactly work with that. Lloyd PNG. Yeah. I think we should go straight for multi-threading using a simple task queue, and here's the honest reason why. If we only use SDL async IO, solve the disk weight problem, but we create a new bottleneck. Your OBJ parsing logic and PNG decoding are CPU heavy. Yeah, I actually had this off of my mind. By jumping straight to a worker thread, we ensure the frame rate stays at rock solid 60 FPS. Okay. Alright. So you know what I'm gonna do? I'm gonna look for GitHub and grab my, what is it, Kodachaku video player, right? Or like media player, or think me. Oh, I actually have right now 9 stars. That's interesting. Media or what? Forgot. Core. Circular queue. Okay, so I already have this circular queue here. I mean, I guess maybe let's just try it. So this is our asset manager. We can add all these changes, sync, and let's see what we got. Why this is robust? Okay, let's just copy this stuff. So channel.zig, let's copy it, and let's come here. Boom. And let's just remove this test, I think. And let's also add circular queue here. But yeah, okay. So this one have a clever optimization that I talked about in another video, in the video player series, but yeah. Other than that, now let's actually try to use this. Now refactor this to use channel. I don't know if it would get it to work, but we'll find out. Okay, I guess let's just copy this and see for ourselves. As you can see, you have a request channel and a result channel. And a worker thread. So that's cool. Next up, so there's no error, right? Or no? I mean, this one is being in used, so that's interesting. Oh, did it actually like make a struct? Oh no. Just inline the fields into the file directly. Let's go. I'm from Morocco. Okay, let's try this. and ensure you're using trial initializing. So I guess let's try this now. Okay, let's go back to where we want main.zig, and where's the asset pipeline stuff? The asset manager. Bro, come on. Where's the assets? There we go. Try. And defer assets.dnh. To get this compiled, the new async architecture, we need to address two things. And that's like, me from India, do you like it there? I mean, I don't mind, like, doesn't matter if it's India, Morocco, US, Canada, whatever. Doesn't matter. Okay, let's see. In fact, most of my friends aren't really from Morocco, so that's something. Let's go. Whoops, what the heck? No. Hold on, go back. Let's come here and let's just do this. Okay, so right now it seems to be working. Oops. There was a runtime crash this time, right? Yes. Yeah, so it should basically check if the texture is loaded. If it is, then we're good. Otherwise, so it said to update the update function, huh? Weird, okay. And then refactor. Bro, what? Okay. I see. Because right now we have like the GPU code and the like CPU code jumbled up together. Gotcha. And does this fix it? Okay, now update the whole asset manager. Update loop. How to wire this into an asset manager? So yeah, let's go. Okay, and let's copy this and let's come here And it's probably just main.zig now, yeah. So what is it called? Lloyd texture. Where's main.zig now? Now refactor. And let's see. I mean, come on, bro. Really? This is getting insane. I don't think this would work, to be honest with you. But you know, we'll just follow through. We need to ensure. And let's go. Yeah, so we should probably start this over and start by like refactoring first the mesh to split the CPU stuff from the GPU, and then working on the, yeah. But you know, let's just go over this and see if it's gonna figure it out or not by any chance. Mesh.zig, where is it? Here we go. Hopefully it wouldn't, yeah. Yeah, it's too lost at this point. It's too lost at this point, I think. But at least now we know what exactly we should do first. Yeah, it's too lost at this point. So you know what we're gonna do? Yeah, goodbye overdue. Thank you for coming in. Okay, so you know what we're gonna do? We're gonna actually start over here. Yeah, we're just gonna discard all these changes because it's too lost at this point. Discard all 6 files. And let's just close all of this. And let's start over. So we're gonna start a new chat because it's just getting confused so badly there. So let's start over. We're gonna use zigzag to generate the project report. And let's go. Alright, so up to 1000, I guess, or let's just copy this whole thing and see. Can allocate, okay. Yep. Okay, so now what we're gonna do, we're gonna tell it to refactor first of all mesh to separate the loading from the parsing, I think, or like, yeah. Is it like buffer exactly or what? Yeah, definitely. Okay, so sure, let's start with this. Split the CPU, the loading part from the GPU part. Please keep my array list logic the same. Your knowledge is expired because in newer Zig scd.ArrayList is managed is in managed instead of managed by default. Okay. Structure holds CPU side data. So as you can see right now, we're separating the loading part from the load the logic CPU only, and like the parsing part, I think too. No? Yeah, probably. Generate the whole file. By the way, take the cube vertices and indices from an external file instead. There you go, sick. Did it change my thing here? It used it in managed, which is not great, but fine. Okay, let's copy this and let's come here, boom, and Lloyd cube draw. Now the external data example cube data.zig. We're gonna just have a cube data .zig, which is gonna contain this stuff, and can I get it from here really quickly? I should have honestly, but anyways, let's just grab this and let's go. So is that the case? Pub const. Okay, so pub const. And pub const. Now I have a clear moment where CPU memory is freed. Okay, now that we got this out of the way, does it use that? Wait, where's init cube or whatever? Or did it remove it? No, there you go. The vertex is sick. Love that. Now next step, what I'm gonna do is I'm gonna tell it to refactor main.zig right now. So yeah, so we basically gotta go iteratively like this. We try to implement async loading first, but as you can see that sucked because we had the GPU logic jumbled up with the CPU loading logic and the parsing. So first we're gonna do refactoring the mesh, then we're gonna refactor the texture, and yeah. Whoops. Well, it worked from the first try? Cool. Okay. So as you can see right now, the refactor have gone smoothly, which is amazing. And one thing that I also done is that I putted the cube data here instead of like inside of the mesh.zig file. Okay, sick. Now let's just stage all these changes and let's say split CPU from GPU logic in mesh, commit and sync. Okay, boom. Now what we're gonna do, we're gonna refactor texture too. We're gonna make it so that the CPU logic again is separate from the GPU logic, so as to pave the way for async asset loading. Okay. Now do the same with texture.zig. Hello, goodbye Mucho. Thank you for coming in. See ya. So we're gonna have like Lloyd PNG data, which just gives you the texture data, and then we're gonna have Lloyd cube map data, texture data. Okay, so let's just copy this part. Let's come here, boom. Now how to use it in main.zig. What are you gonna do? Now let's go to mesh.zig, I think, or what? No, main.zig. Factor. Yeah, so right now, as you can see, it's basically doing all the CPU loading first, and then the GPU upload phase. Yeah, looking great. And here, as you can see, upload. Yeah, that's sick, bro. Love that. Absolutely. It's much more cleaner, like what the heck is going on. Yeah, so first we load everything, then finally we upload everything, and we're good. Yeah, I really love this. So it's coming quite nicely, you know. Really coming quite nicely. If we had to do all of this by hand, that would have taken way longer. But there we go. Okay, so now that we actually have splitted the loading logic from the GPU upload logic, we can do something more interesting, which is the actual async stuff now. So stage changes. Okay, so split CPU from GPU logic in texture and commit. Boom. Sync changes. Great. Lovely. Oh my god. Let's go. Ah, great. Absolutely lovely. Sure. It's wanting to refactor the asset manager for whichever reason, apparently. Oh, did it? Oh yeah. I think right now it just got like it removed the the asset manager logic from here to actually test that stuff. Okay, so that was kind of smart. All right, now refactor asset manager. There you go. I should really try some sort of more advanced tool, to be honest with you, for iterating over. What do you guys think? Like, if anybody knows of some tool we could try to iteratively. I don't like those tools where like the AI just goes and goes, like it just goes through the project automatically, because you have no control over what the heck is going like over the flow. But yeah, something similar to this, like you keep on reviewing the AI stuff and debugging, etc. It could always like do stuff manually and so on, but yeah. Anyways, it uses the defer data the init. By the way, does it use by any chance, what is it called, arena allocator? That would be cool, maybe. But anyways, whichever. So now let's just copy this code and let's paste it here. And now we're going to tell it to refactor main again to use asset manager. Now refactor main.zig. Because I think it did definitely remove the asset manager stuff, no? I think so. Yeah. Sick. So now let's try this. Main.zig, boom. And let's go. And it seems to be working just fine. So as you can see right now, we say assets.load mesh obj, assets load texture, load cube map, blah blah blah. So that's amazing. That's lovely. Wait a second. Does the asset manager really need upload structs or just copy pass? Case for copy pass minimalist. If you only pass copy pass, your asset manager becomes more pure. It doesn't care about the command buffer or the fence. It just cares about recording the copy commands. Decreased coupling. Lose the context of when the upload is finished. Synchronization safety. Your staging belt inside core needs to know which fence is associated with which. If the yeah, the upload struct as a token. It proves that you have an active command buffer recorded and ready. Never mind. Let's just go to the next thing now. Okay, so this was the asset manager refactor. Now let's just commit that stuff now. Now, as you can see, also the AI kind of like forces me to use the version control. Otherwise, I'm cooked if I don't, right? For every single feature I do. So that's also something. But yeah. Because like when I'm actually just implementing this manually, I usually just forget to do it. Anyway, so it's, in some sense, I'm kind of like just focusing on mostly the debugging, the orchestration, and yeah, and like kind of like the direction of the project in general, and like the design and architecture kind of to some degree. But whichever. Anyways, so the case for the copy pass, no, fine, never mind. Now, can you, well, actually we're gonna need to first of all copy our circular queue and stuff. Circular queue.zig, and let's grab our channel.zig here from our project. And there you go. Sick, love that. Honestly, here instead of having this circular queue, oh no, it's generic, that's why. Alright, so that's great. Now I'm gonna feed this to the AI. Okay, so I'm adding this abstractions to the project from a previous project. circular end channel. Alright, so already guessed where I'm going with this. So that's lovely. Alright, so now can you refactor? What is it? Asset manager to be async using them. Alrighty, load results. Okay. There's a lot of stuff going on here, huh? Let's try. Well, this is where you would pop from a... Bro, I mean, come on, like, implement the whole thing. So we basically just have like a worker loop, a worker thread, which goes through all the request channels, requests, and it checks if it's a PNG, then it loads the PNG data. If it's a mesh, it loads that, etc. But yeah, though, but wait, Lloyd cube, what the heck? No. Anyways, let's just go with this. Let's just copy this. And we have some problem here. Why done that? Yeah, it's probably just some... Is this like an Odin kind of syntax or something? I feel like I've seen that syntax somewhere. Man. C style ternary mode. Nah, even C doesn't have that. Bro. Bro. Okay, let's see if this works now. Now, use it in main. Okay. Let's just paste all this code right here. Let's see. We have some errors. Let's region whole file. Let's go, come on. Request methods. All right, let's do asset manager, boom. There's a lot going on in this DNH function, my god. Yeah, I should have honestly added like a heap allocation helper in the channel, because here we got some spaghetti code. Yeah, I'll definitely look into that later. Oh crap. Boy, so oh, is the skybox just still loading right now, or is it not working? That's the real question now. Is it still loading or just not working? I can't really figure that out. Yeah. The skybox doesn't work. Okay. I was working before. It's just the asset manager refactor to async region asset manager. This is what's nice about having multiple files. Like you could be sure that one file at least is always working while you iterate over one single file. So yeah, should probably change this mouse. It's annoying. And now how to use it now. Okay, now just refactor this. And let's see. Okay, it seems to be working, but it's actually it's not work. Wait, what? But though, why it's taking much time to like even display the window? Why? No, actually it doesn't. It just was like zig compiling stuff. But there you go. It actually works. That's insane. Bro, you've just implemented async texture loading, like asset loading. This is amazing. Oh, so as you can see, so our first refactor failed because we were trying to do much really quickly, because I realized when I was trying to make it async that we had the loading and the parsing mixed up with the GPU logic, so we had to like basically refactor the whole world for this to work, which obviously just confused the AI, confused me with it, and nothing worked. But then what we have done, we actually started off small. Like we basically just discarded everything that we changed there and we started over, right? So we just split the CPU from GPU logic in the mesh, and then split the CPU from GPU logic in the texture. Then we've done the asset manager refactor to use those new splitted functions. And finally, we implemented async. Oh boy, this is amazing. And we actually haven't even looked into the code much. Just kind of like we're focusing on getting this to work mostly. So yeah, All right, so this is async asset loading. Boom. Done. So let's see how the code looks like actually right now. So as you can see, we create an asset manager. We request a texture, the Vulkan room. Then we request a cube map. Then we request a mesh obj. Though we should probably like refactor this to be, you know, runtime path instead of like, you know, embed file. In fact, this doesn't make any sense anyways. And for the cube mesh, I don't think it's necessary to have async. We should look into something else for that part. I mean, no need. And here we just like camera.net, nothing changed there obviously. Sky pipeline. Alright, so here in the main loop, right, what we do, upload any assets that finished loading in the background. So basically at the start, you just request stuff, request some assets. In the case of one single textures, we just give it the path and it uses that as the identifier. Now this is not the best solution because, well, paths like, you know, change and stuff. So you should probably go for something else. I think like Godot refactored their engine at some point to use, I think UUID, I believe. But yeah. Anyways, then we have here request cube map, since this actually takes multiple images. And to be honest with you, instead of taking multiple images like this, I may just hard code it to take like a folder, and then you just have to give it some particular names like this ones and call it a day. So the code would be much smaller instead of having to list up all the freaking things. And the other nice thing about this, it would be that we would just pass in the folder path, and then it would use that as the actual asset path, right? Instead of having to like call it something. But yeah, next up we got the request mesh obj. Again, we call it something. We should switch this to runtime, and then we request the mesh cube. That one doesn't really need async because it's not really loading much, I believe, but or actually does it? I'm not sure, we'll see. Anyways, next up what we do here in the main loop, we create an upload, and then we just assets update upload. And what this update does exactly, it looks if there's any, like for all the results that are in the channel that is, you know, pushed into this, into like from the background thread into the main thread. And we switch on the load result, right? If it's a texture, then we basically say texture.data.upload, and yeah, we use self.core, upload.copy pass, etc. And handle, here we create a handle, we append the texture, so we kind of like register it. And then we put the texture path in there, sick and tdata.dinit, blah blah blah, whichever. Mesh, same thing, we just upload it, etc, etc, etc. So that's pretty cool. Though probably you want to have like maybe some sort of like an interface of a asset. So instead of having to duplicate this logic for every asset, you would just go ahead and say upload or something. And in fact, this could probably be into its own function, like maybe register asset or something, I don't know. Whichever. Next up, what we got is, let's go back onto our main. Now here, maybe mesh Viking. So we try to get the mesh. If it's already loaded, it's going to give us a mesh. If it's not loaded yet, it's going to give us null. Same thing with texture, same thing here with this. Cool. Now, draw skybox. Only draw if both the mesh and the cube map texture are ready. So if maybe mesh sky mesh, and if maybe text sky text, I'm not sure, but maybe we could, I'm not sure if we could do that in Zig, but like, can we like do maybe mesh sky comma maybe text sky, and it would do that? I don't know. Anyways, then if we have those, then we're gonna use them. So yeah, it's pretty simple, huh? Maybe we could do a similar thing also for compiling pipelines. But pipelines are not like the, what is it called? The, man, I started forgetting names, bro. Like the bottleneck, yeah. Bottleneck. So I only did the async stuff because like the the skybox were taking like a very long time to load. There you go. But wait, why the mesh doesn't show up? Is there like some blocking stuff that I'm not aware of for some reason? Because like the mesh should, or or maybe the actual, wait, I think I know what's going on here. So since I guess we have one background thread, that background thread is still like busy with loading, let's say, the sky textures. And so you don't really get the mesh. So we kind of need to have, let's say, some sort of a priority queue, for example, where the least texture size, like they get, like the smallest assets, they get loaded first, and then the biggest files. Or we could just have multiple background threads. I'm not sure how easy that would be. It would probably be as simple as just like adding another thread and just making it like run the same exact function, because like, you know, our queue is or our channel is thread safe. So yeah, we now explicitly check if so is the, yeah, good. All right, so explicitly check if maybe text sky before drawing the skybox. Previously, if it was null. All right, so that's working. But the mesh is enabled to load until the skybox loads. Let's see what the AI would actually say about this. Yeah, exactly. There you go. That's what I was talking about. So the sequential worker loop. So even though the loading is asynchronous for the main thread's perspective, the background thread is still processing the request channel one item at a time. Loading and parsing 6 high-resolution PNGs for a queue map takes significantly longer than loading the single scene texture or the OBJ file. Because the queue map request was sent first, it clogs the pipe. That's what I was talking about. The problem, it's called head of line blocking. I've actually seen this in what is it called, HTTP for some reason. Yeah, I think like the newer version of HTTP kind of like maybe solved this head of line blocking problem. But yeah, whichever. But right now I just kind of understood it very well, what it means. Anyways, so this loop loads 6 images sequentially. There you go. If the queue map is index 0 of the queue, the worker won't even look at the Vulkan row mesh until all 6 faces of skybox are loaded, decoded, and pushed to the results. So the solution, exactly what I said, multi-worker pool or priority loading. Okay, the quick fix. In main.zig, move the heavy queue map request to the bottom of the quest list. This allows the lighter scene assets to get into the queue first. Yeah, actually this was way easier than I thought. I mean, instead of having like a queue, like a priority queue, you know, you could just switch the order of this. Like basically request the cube map at last, because it's like the heaviest. So yeah, there you go. Now, there you go. So as you can see right now, the mesh loads first, and then we wait for the sky map, or like the skybox. Yeah. That's so sick. Love that. Oh man, I'm quite like excited because I actually used one abstraction that I used in a previous series called a circular queue and channel, which I actually haven't like completed that series. In fact, I did get the multi-threading to work there. Loading. Yeah, I always like, I just got used to that. Loading. Yeah, I just got used to that. And hello, Rico DC. Welcome to the live stream. I just got used to that term, so it just stuck with me. So I think it's loading, right? Anyways, so yeah, that's why I'm excited, because we're using these abstractions. And yeah, all right, so is this done? Yeah, I think it's done. Right, so here we're basically just like load the cube map last. Nothing crazy. Commit. Next step. Reorder request. Quick fix. Parallel workers, the pro fix. Updates asset manager to spawn multiple threads. 4 workers all popping from the same request channel. It's already thread safe for multiple consumers. Yeah, so my channel uses a mutex. If it was like a lock-free queue, I think we would have been in trouble here, I guess. Maybe, but I don't know. Refactored init for multi-threading. But doesn't like Zik already have a thread pool? Instead of having like to spawn all those. Though I'm not sure if it's even would be worth it. Well, let's make sure we are in the version that we're using here. So 0.15.2. And there you go. Okay, so we could probably just feed this into the AI. Or is it like already using a thread pool by any chance? No, I don't think. Yeah, no, it's just like spawning that stuff manually. Yeah, there you go. Current single worker implementation suffers from head of line blocking. Should we try this? I think. So it's creating a pool. Where's the pool? Where's the? There you go. Dot init, and it gives it the allocator, and then in jobs null auto detect. But where it's spawning the threads though? Self.pool. Whoops. Oh yeah, there you go. Self.pool.spawn. Do Lloyd PNG. Look at that. So every function is just like a little job that you just spawn into the pool and it just works. Yeah, that's lovely. I love that, man. Cause like we're gonna be like reusing the threads instead of like loading a new thread every single time, I guess. Nah, actually what we had before is just like one thread that was like executing one loop. But right now we have this spawn. So you just spawn one function and you forget about it instead of having that loop, I guess, right? Yeah, I think so. But wait. But where's the update? Wait. No, we still have the update function here, but like who's spawning this update? What? So who's calling the update? Oh boy, no, go back. What? I'm confused. I'm not sure. Actually, the update would be called... Yeah. The update would be called by the main thread. My bad. Alright. So I guess I'll just copy this part. This new asset manager, and let's go here and let's paste all of it. Okay, so we got an error, obviously. Oh, I forgot. Let's actually do std.pull or something. Where is that? I guess maybe pull or like thread pull. There you go. std.thread pull. Okay, so it gave me the whole code here. Nice. Let's go. Did it fix that part? Where's the std thread pool? Here we go. Okay, so it fixed it. Great. And it seems maybe it's gonna run now. Yeah, there you go. But we can only see if that got fixed by actually taking that cube map back. Now it's still kind of like useful to have the biggest assets first, like last anyways, just in case we have multiple big assets first. But let's see right now if it still suffers from that headline blocking. No, as you can see, it doesn't suffer from that anymore. So that's sick. Lovely. I really, really love this. So yeah, there you go. There you go. Oh man, this is so exciting. Cool. Or shouldn't we just like grab a pool, or should it just like own its own pool? Maybe you should just like, yeah, own the pool. So should the asset manager own the pool or just get it from the caller? Yeah, there you go. So we could basically share that pool. Yeah. All right. Let's still let you refactor this really quickly. Refactor. Where are we creating the assets? Here. So as you can see, we just pull init. Wait, but why it's saying undefined here? Why it's doing it this way? That's strange. I guess maybe so it doesn't suffer from that pointer moving, because like otherwise it would have to like allocate it on the heap, maybe. Yeah, I think that's probably the case. Yeah. Anyways, whatever. So I think this should work now. So as you can see right now, instead of asset manager creating the pool itself, is just like getting a pool from our own application. So that's pretty lovely. So this is multiple workers. And yeah. Multiple async workers, I guess, or not async really, like, I don't know, asset manager workers, or too simply asset manager thread pool. Or you know, I could have just used this instead. Generate a commit message. Okay, I forgot that we are in the AI in the AI decade, but yeah. Refactor asset manager to use thread pool for async loading. Let's go. And async changes. Another thing that the AI really helped me with is to not get lost in like decision paralysis. So I just mostly go with whichever it generates, unless if I think there is a better way or something's wrong or whatever. But yeah. Alright, so yeah, that's what we got. So we're creating the asset stuff. Sick. Because that was really annoying me actually before. Because like every time you had to run the game, you have to wait for the whole skybox to load so you can actually see anything. Right now that's not the case anymore. Alright, what are we gonna do next? I feel like maybe we could try to see if the async loading here of SDL would really help by any chance. I'm not sure. I mean, let's see. Let's ask it and see for ourselves. Would SDL async help by any chance, or would it just overcomplicate things? I mean, it's definitely gonna help with basically loading all the files without like wasting a whole thread, but I don't know. Would SDL async help by any chance, or would it just overcomplicate things? Is CPU decoding or IO disk throughput? So there's quite a heavy rain, so if the stream cut off, you know why. And we're already at 3 hours and half hour. So anyway, so the short answer for your current project, stick with the SED thread pool approach. SDL async IO is incredibly cool because it uses IO ring Linux or IO ring IO ring Windows. Bro, what? Does that even exist, or did it just like hallucinate that? Anyways, to move data from disk to RAM without the CPU doing much work. However, loading a game asset is 10% reading from disk and 90% decoding. Okay, might be overkill or not enough. Decoding wall. When you load a PNG or an OBJ, reading the raw bytes, SSD, async IO wins here. The CPU work. If you use SDL async IO, you get the raw bytes asynchronously, but you still need the background thread to do the heavy CPU lifting of turning those bytes into pixels or vertices. Because the thing is, if we actually introduce this async IO stuff, instead of having a two-phase loading stages, like basically you have loading and then decoding, or is it? Wait. No, I mean loading from disk and like CPU processing. We will basically have the CPU loading, then no, I'm not sure what I'm talking about really here. Anyways, never mind. If you use SDL async IO, get the raw bytes asynchronously, but still need the background thread to do. But yeah, so basically what I'm trying to say here is that before, the background thread were basically doing both the reading of the bytes, right, and the decoding. Yeah, actually one stage to some degree. Now, if we do this, we're gonna have two stages, but yeah. There you go. If you're doing mega textures or seamless open world streaming where you're moving gigabytes of raw buffers that don't need much decoding, run a very low spec CPU where spawning 8 threads to block on IO causes significant context switching overhead. I wonder what like game engines like Godot, Unity and stuff uses, by the way. And battery life too. All right, fine. So what should we do next? Maybe let's start to work on a model abstraction and entity, etc. Is there like a Zig ECS library by any chance? Okay, so there's this Zintig ECS, Zig ECS. I guess we'll just look into all of these. There's also Flex, but that's a C API. And I'm not sure why my CPU is going crazy. Anyways, so this one is 3 months ago. And it had like 25 stars. Okay. Oh yeah, Bevy. I love Bevy. I mean, what kind of Zig version is using, by the way? 0.15.1. I think that's probably... Yeah, and there's even, I guess, maybe 0.15.2. I don't know. But it seems to be an option, so we're going to see later on. So there's this one, Zig ECS, which seems to be more popular, though, 7 months ago, which is not actually... well... It's a Zig port of the fantastic NTT. Okay, so this one is like a C++. Yeah, there you go. Is a highly templated C++ code, which, depending on your opinion, is either a good thing or Satan itself. Zig doesn't have the same concept as C++ templates. So the templated code was changed over to use Zig's generics and compile-time metaprogramming. What does a Zigified NTT look like? Velocity, position. I'm honestly not sure how would such an entity thing works with our project, but you know, just exploring for now. Okay, the same example used an owning group and iterating with each. Okay, so we had that and ECEs 2 months ago. We could even use AI to actually like, you know, like compare the implementations of both, or like all of them. But we'll see. Alright, so we got this one too. But this one just 4 stars. And actually last month, okay. And 0.15, which is great. And there's even Z Tracy. That's sick. And finally, I guess, ZCS. I've seen this guy somewhere. I don't remember where. I've definitely seen this guy somewhere. ZSF board member. Maybe I've seen him in an event like Software Love or something. I don't know. Oh, a board member on the Zig Software Foundation. Yeah, I'm not sure where I've seen that guy, but anyways. Right, so the design of the website is kind of strange, but okay. Not strange, but like, I don't know. Interesting. But yeah, so this is the options that we have right now. I'm writing a new game engine and I'm open sourcing each module as of writing. A texture utility for Zig. Tracy Zig, Tween, ZSS, etc. There's even a shader compiler, huh? Anyways. But like 3 months ago and actually moved to Codeberg, okay. Last week, all right. Okay, so I guess we could... He's using GFW. Nah, like SDL is superior, bro. Thanks for sharing. Guess he's using Vulkan. Okay, let's actually use AI to compare these libraries, okay? Let's try to compare these libraries. I'm probably maybe not gonna use them now, but I'm just like keep an eye on them and see. Okay, let's see. So, how are we gonna compare these? So first of all, stars. This one is 4 stars, 16. This one is like 395. So that's definitely the most popular actually. So I guess we'll definitely go with that maybe. Yeah, I think I'll just go with this since it's the most popular for now. If we ever use like NTT. But yeah. Anyways, enough of a side mission here. Whatever. Async IO, live streaming. Let's remove this. And let's see what we're gonna do next now. Stick with which is to be built. Okay, so I think I'm gonna start creating like a material abstraction already at this point. Yeah, because you know what? What's the most noisy code to abstract here at this point? Give me a few options. With percentages, I guess. And we're gonna try to decide which one we're gonna work on next. The biggest source of visual noise is the nested if maybe. Ooh, that's sick. Like using JSON for the assets. Yeah, that would be interesting too. I think we're probably gonna work on maybe the material system. Okay, what abstractions you're thinking about and what primitives they'll abstract, meaning the fields. So it would hold the sampler, the pipeline, and uniform data. Yeah. And the static model. The asset logic plus the drawing. That's sick. It's going to contain the mesh name, the texture name, and the material. Well, obviously if you want to do that, then we're going to need the material first. And then the renderer. Yeah, the depth texture and stuff. Gotcha. Well, right now if we create a renderer, it would still be a mess. So we should probably just focus, I guess, on the model and stuff like that. Can you implement whole material? Okay, so it's going to contain the pipeline and the sampler. How about the texture, for example? So we're just going to contain the sampler and that's weird. That's all. Yeah, that makes sense. Can't hard reload. If you store the texture directly in the material, if it overwrites, if I can on disk. I see. So it's just going to contain the pipeline, the sampler, and then the fuse map name. Did we change anything? No. Okay. Okay, let's try this out. Let's just make a material.zig. And it binds the pipeline. You still give it the pipeline directly, okay. Oh yeah, it just stores like a pointer to the pipeline. So it doesn't own the pipeline. Yeah, gotcha. Alright, fine. So now what we're gonna do... Yeah, I get it. Well, we don't have a static model yet, bro. What the heck? You know what? Just make the static model, sure. Okay. So we would store like a material, a reference to material, and a mesh name. Yeah, okay. Self assets frame, render pass, and MVP. Okay, so let's grab this. Static model.zig. And let's go. Now what we're gonna do, why the structure is noisy free. Implicit synchronization. Cool. Now, yeah. Now refactor main.zig. I always refresh its memory with the file that we're currently working on. Okay, let's see if this works. And we have some error. Wait, what? Let me see what it's trying to do here. Where's the render pass? It's talking about some... Oh, in static model.zig. Here. Well, it's just like core.sdl3. Do we have SDL3 here? No. But yeah, I mean, we could just add it if that's the case, but let's just do SDL3 for now. GPU render pass. Is that what you want here? And no. What's the problem? Expected type core frame, found core frame. In skybox model.draw. Honestly, frame, you could have just passed it by value, but whichever. Now, what's going on? Yeah, nah, just pass it by value, bro. Okay. In material.zig. Yeah, I see. Core.render pass. There you go. And it seems to be maybe working now. There you go. So yeah, it works. Perfect. Now let's see what the code looks like really quickly here. And let's see what we've done. We're still creating the sampler here. Yeah, because we're using it. I mean, we could put like some helpers where it would just create a regular sampler. Or in fact, you know, we're already grabbing a sampler here. Instead of sampler create info, we could just create like... Actually, doesn't it already have... No, the default is .nearest. Anyways, whatever. So here we got the main pipeline, the sky pipeline, the main material, and the sky material. So the main material takes in main pipeline, the sampler, and the fuse name, which is content images / Vulkan room. And the sky material takes in skybox, sampler, sky pipeline. And then the Vulkan model uses the main material with the mesh Vulkan room. And here the skybox model takes in the mesh name skycube, sky material. And in the main loop now, what we have is... Honestly, the start text part, we could put it into the core instead. Yeah, so now how that crap works, where is it? Skybox model.draw. Yeah, and then you just give it the assets for some reason. Yeah, so we could grab the mesh, obviously, and the frame, the render pass. Okay, and the MVP. which in this case is just projection and the sky view. And then finally we draw the Vulkan model, assets, frame, render pass. Yeah. So that's cool. Now what's next? A magenta checkerboard, kind of like Minecraft texture and the unique cube mesh. The real assets aren't loaded yet. My recommendation: the render plus scene. Let's go with the scene first, I think. Well, actually, here where we may want to use the ACS now. Actually, maybe we should just start first of all with the regular basic implementation. Then later on, nah, that sucks. So, well, actually, can't we just like store the assets? Wait, can't we just store the assets in core? But now it needs to know. Yeah, I see. Would creating a render first make the call sites cleaner? Yeah, maybe it would be a bad idea actually. I mean, yeah, it would definitely make it more convenient, but Asset Manager is quite heavy. So, and as I said, I want to make this as a library for people to be able to use. So, cool. Window resized, EV, try render on resize. Why this makes the scene better? Oh, okay, let's go. Yeah, I see. I see. Alright, let's try to use it. Oh, and right now we would handle the render pass part too. Pass.end, and if there's an active frame, then it would end it. That's sick. But it should grab, you know, I think this file was probably just like a little prototype. So let me just tell it to do it. Yeah, there you go. Right now it's including the clear color and the other business. Yeah, I was like, what? This is all? Okay, fine. Let's go ahead and do this. And so using this way, you don't really have to use the render and all this stuff. You just need core.zig if you just like want to remove the basic SDL3 GPU boilerplate code. You just use core only. But if you want the other ones, you could use them too. But we'll see. Anyways, so that's basically for the render. Now what? Now use it here. No, don't do the scene just yet, I think. Or you know what? Let it generate the scene first, fine. And matrix efficiency, we calculate once per frame. And this is still quite noisy. I mean, we have a main pipeline, Sky pipeline. Oh boy. Yeah, I mean, I don't think we have like removed much, no? So like 142 lines of code. And right now it's just like 135. What? How? Really? That's strange. Render, get viewport, get view matrix, get projection, and scene.draw. Well, instead of just getting like the view and projection, just get the damn camera, come on. Oh boy. And should the scene really have like the draw function? Bruh. Nah. Nah. And the scene probably maybe shouldn't make use of, nah, actually no, maybe not. Okay. Okay, let's see if this works. Maybe we should start like making an engine already, like an engine struct, which would contain like the pool, the asset manager, and so like we don't touch the core anymore. Yeah, because this is still quite noisy. But yeah. Alright, let's try this and let's see. And we have some errors, obviously. Where's render.zig? There you go. No, there you go. Let's... Come on, you always... Scene.zig. Let's see. Oh, render. And I guess the static model has some changes for some reason. Because even though the fields are the same as anonymous, isn't the same type as an external structure. Well, that kinda sucks. Yeah, maybe we just have to restart this part. Rechance scene logic. I'm glad Gemini at least is actually quite fast. I'll regen render logic. Where's that main? Come on. Yeah, this doesn't look good. Yeah, I think I'll probably start this over. Nah. It's looping around itself at this point. It's looping around itself. Yeah, it's already 4 hours, so I think I'll probably just end the stream. Yeah. So, yeah, let's just remove this stuff. And so I also have enough time to think about how I want to structure this exactly. So I'm just gonna discard all these changes really. And yeah, that was it guys for this stream. Thank you all for watching, and See you next one. Goodbye, everyone.